The loops we'll take a look at today are the for each, while, and do while loops. The for loop starts with an initializer, telling the loop where to start. Next, there is a terminator, signifying what condition should stop the loop. Then a step, either decrementing or incrementing the counter. Each time that the loop successfully iterates, the code inside the block is executed. The for each loop iterates just like the for loop, but gets its name from doing so for each piece of data in a collection. You must specify the data type along with a variable name, colon, then the name of the collection you are iterating through. The while loop reads much like plain English, executing so long as a specified condition remains true. While that condition is true, the statement within the block will be executed. The last loop simply adds to the while loop. The do while loop ensures that something is done so long as a condition is met. Its only real difference from the while loop is that the code in the block will be run at least one time. Alright, let's take a look at first a for loop. So we're just going to put in here a declared variable. So we'll start with int I, that I just standing for iteration. It's just a kind of short name for that. So I starting at 0, we're going to increment up and we're going to go to 5. All right, so if we start there and we say, okay, go until I is so long as I is less than 5. What that means is that once I hits the number 5 and is no longer less than it, it'll iterate one more time to check. Like it'll come through and say, okay, I've got 5 now. Is it less than 5? No, it's actually not. And so it won't execute the code that we're going to put inside here. In order to make sure that we do get to 5, right, and not get an infinite loop, which would crash our program, we put I, put the increment, open up some brackets, and we could really put anything in here. Sometimes I just type out a simple, it worked. I'm going to go ahead and make that a print line statement, and we'll go ahead and run it and see what we get. We see down here we've got 1, 2, 3, 4, 5. It started at 0, counted up to 5, so it went 0, 1, 2, 3, 4, checked 5, but didn't execute for 5 times total. Now let's take this and go backwards. All you'd have to do in order to work backwards with a for loop is essentially change where the start and the finish are. So in this case, if we know that we want to end at 0, we're going to want to start at 5. We'll flip the sign. And this time we'll decrement to make sure that we don't get the infinite loop. And this should walk backwards. It should start out at 5, keep working until I is no longer greater than 0, and this condition here can't be satisfied. And it'll work backwards towards that goal. So let's run it and see what we get. Same output, so we know that it worked. So that's incrementing and decrementing with a for loop. Let's take a look at what it would be like to work with a for each loop. So for each loop is used oftentimes when you have a collection. So say for instance we had a string array and it was called fruits, and it was, let's say we have apple, banana, and cherry. All right. Gotta get my brackets there, right? All right. And so we have this array of fruits, right? And it's just literally the strings apple, banana, and cherry as string literals. All right. So down here, this is a really simple loop. It reads like this: for string fruit. Now you could name this anything. You could literally type clown shoes here instead, even though that wouldn't be very semantically helpful. But string fruit in, the colon is pronounced in, fruits. And we could just print out those names of those fruits there. So you could just say fruit, right? And then once we run it, we see it prints out apple, banana, and cherry. So we got our input. Good deal. Let's take a look at the while loop. While loop can be easily used by implementing some type of counter. So let's say we had a counter and we set it to 10 and we want to walk down to 0. You could say while counter is greater than 0, working just like our for loop. Now you'll have to make sure that you do handle the case. You're going to have to manually handle the counting down here, but we'll see how we do that. You could say system print line, and we'll just go with it worked again. And now we need to handle counter decrementing. Go ahead and run it. And we see we get it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times, right? To flip that, all you do, start at 0. Say counter, go to 5 or go to 10, or you could do whatever number here. Make sure you change your decrement to an increment so that you're actually reaching your goal here. Oh, I need to flip my sign. I was wondering why that didn't work. Flip your sign. And there we go, 1, 2, 3, 4, and 5. We have 5 bits of output there because we counted from 0 to 5. Last, we'll take a look at our do while, which works very similarly. Like we said, the only difference is that here the specified condition will always be done once because we start there. So we'll say dot out, dot println, and in here we'll say it worked. Down here, we specify our condition. So we'll say while counter is less than 5. And we need to handle in here incrementing. So we'll say counter, count up, we run it, and we get 1, 2, 3, 4, 5. Now, the interesting thing about this is the condition could be totally false, and like we said, it'll still execute one time. So in here, I could say, so long as counter is greater than, or we'll say is less than 0, right? Which isn't true. Counter is 0, and when this comes through, counter will be incremented. But we run it, and we see we get 1 bit of output because it's going to do and then check the while. So it's more of a pre-check operation than it is a post-check operation. So cool. Those are your loops. You can go use them now. Try them out in your projects. Have a great day.